How far can the sun's light travel? Can it reach the edge of the universe? The energy unleashed by the sun sweeps through space at the speed of light, 300,000 kilometers per second. It bathes Earth in warmth and gives birth to life. But does this seemingly endless radiance have an endpoint? Can it really reach the edge of the universe? This grand journey of sunlight hides one of the universe's most magnificent answers. The speed of light is the ultimate limit of the universe. It can run from Earth to the moon in just 1.3 seconds. But the scale of the universe is far beyond imagination. Even at light speed, interstellar distances are measured in light years. Sunlight takes 8 minutes and 20 seconds to travel from the sun to Earth. If the sun were to suddenly disappear, we wouldn't notice the sky darken until those 8 minutes and 20 seconds had passed. That brief delay is only the starting point of sunlight's long expedition. As distance increases, sunlight gradually dims and weakens. Yet its journey never truly stops. After reaching Earth, sunlight continues on to Mars. Mars lies 228 million kilometers from the sun, and sunlight needs 13 minutes to get there. Its intensity reduced to 43% of what Earth receives. The thin atmosphere makes daytime there feel like Earth's dusk. In the red sky, the sun appears as a smaller disk, yet it still casts clear shadows. Jupiter is 778 million kilometers from the sun. Sunlight arrives in 43 minutes, with only 4% of Earth's intensity. Here the sun is no longer a blazing disk, but a beacon 100 times brighter than other stars. Hanging above Jupiter's striped clouds, there is no searing heat, only a faint glow. Sunlight reaches Saturn, 1.43 billion kilometers away, in about 1 hour and 19 minutes. Its strength reduced to just 1% of Earth's, leaving surface temperatures near -178 degrees Celsius. Uranus lies about 2.87 billion kilometers from the sun, stretching sunlight's journey to 2 hours and 39 minutes, with intensity only 0.25% of Earth's. The sun can illuminate this ice giant, but cannot dispel the biting cold of -218 degrees Celsius. Neptune is the most distant planet in the solar system. At 4.5 billion kilometers away, sunlight takes 4 hours and 10 minutes to arrive. Its intensity only 0.11% of Earth's. Here the sun is indistinguishable from an ordinary star, just a steady white point, amid winds of -214 degrees Celsius, adding a faint trace of light to this deep blue world. Beyond Neptune lies the Kuiper Belt, a frozen region, 4.5 to 7 billion kilometers from the sun, filled with rocky debris, comets, and dwarf planets. Sunlight takes 5 to 6 hours to reach this realm, its intensity falling to 1/1,000,000th of Earth's, with temperatures dropping to -230 degrees Celsius. This faint sunlight not only illuminates these bodies, but also records the 4.6 billion year evolutionary history of the solar system. Beyond the Kuiper Belt lies the boundary of the heliosphere, a bubble-like shield formed by the solar wind. 14 to 18 billion kilometers from the sun, sunlight needs 13 to 16 hours to arrive, its intensity falling to less than 1/1000,000th of what Earth receives, appearing as nothing more than a dim white dot in the sky, with brightness only 1/10 that of a full moon. In 2012, the Voyager 1 probe crossed the heliopause. By November 2025, it was about 24.8 billion kilometers from the sun. Sunlight takes 22 hours and 30 minutes to reach it. In its images, the sun is just a point of light, slightly brighter than other stars. Beyond the heliosphere lies the inner region of the Oort Cloud, at least 2,000 astronomical units from the sun. Sunlight takes about 12 days to reach this region. The Oort Cloud itself spans more than 1 light year in diameter, and sunlight needs an entire year to cross it, marking the boundary between the sun and other stars. When sunlight passes beyond the outer edge of the Oort Cloud, it enters the domain of other stars. The nearest stellar system, Alpha Centauri, is about 4.5 light years from the sun, or 43 trillion kilometers away. Sunlight takes 4.5 years to arrive. This beam of light, crossing 4.5 light years, completes its transformation from the star of the solar system into a traveler among other stars. It learns how to visit the neighborhood next door. Passing through the Alpha Centauri system, sunlight continues racing through interstellar space toward the next star system, faithfully carrying out its long expedition. But the Milky Way is about 100,000 light years in diameter. Even at light speed, sunlight would need at least 100,000 years to cross the entire galaxy. Beyond the Milky Way, the most prominent neighbor is the Andromeda Galaxy, 2.5 million light-years away. Sunlight needs 2.5 million years to reach Andromeda, and this is only one nearby large galaxy. Beyond Andromeda lie trillions upon trillions of galaxies, such as the Cartwheel Galaxy, 500 million light-years away, traveling at 300,000 kilometers per second. Sunlight needs 500 million years to reach the Cartwheel galaxy. The most distant galaxies observed by humanity lie 13.4 billion light-years from the Sun. Light itself needs 13.4 billion years to reach them. This is an unimaginably long journey. So how far can the Sun's light travel? The answer is infinitely far. Sunlight is, in essence, electromagnetic radiation. It requires no medium to propagate through a vacuum. As long as it is not absorbed or scattered by matter, it will race endlessly through space. Every ray of light emitted by the Sun today spreads in all directions at light speed, crossing the solar system, passing through interstellar space, skimming past other star systems, and even flying toward the depths of the universe. But we must understand one thing: sunlight traveling infinitely far does not mean it can reach the edge of the universe. First, the universe is expanding at an accelerating rate. Distances between galaxies keep increasing. Some regions are receding faster than the speed of light. Sunlight can never reach those superluminally receding regions. Second, the universe is filled with stars, planets, gas clouds, dust, and other matter. As sunlight travels, it is constantly absorbed and scattered, its energy gradually weakening, eventually transforming into other forms of energy, and merging into the universe's vast energy cycle. More importantly, the Sun itself is not an eternal beacon. It is a yellow dwarf star, with a lifespan of about 10 billion years. It has already burned for 4.6 billion years, and has about 5.4 billion years remaining. When its core hydrogen fuel is exhausted, the Sun will expand into a red giant, then collapse into a white dwarf, and finally cease to shine and give off heat. But the light emitted before that moment will continue to travel through the universe, carrying the imprint of the solar system into the endless depths of space. The journey of sunlight has no absolute endpoint, but it has eternal continuation. It may never truly reach the edge of the universe, yet it can exist forever as energy within the universe itself.